Hi, everybody. It's Tuesday, 3/24. So hopefully you uploaded this file and you've done problems 1, 2, and 3 because those are some review. Okay, so let's look at the first one. So the first thing we started with was to find the area of a bounded region. And I don't know if hopefully your screen's color, but my thing's orange. So I want to find region 1. And so since I can span this with a vertical line segment, I know I'm going to integrate with respect to x, and I need to take the top function minus the bottom function to describe that length. So the top looks like it's the line, so 3x plus 4, and then I have to subtract the function that describes the bottom, which is 1/2 x squared. I'm going to add up all those segments. So I'm going to integrate. And it looks like I want to go from 2, I think it's to 5. Now, if you are planning to get a 4 or a 5, I'm not sure how they're going to do the AP test, but they would think that you could do this by hand, right? Or you could type it in your calculator. All right, now let's look at the next one. Okay, so we're going to still use that region 1 as the base, and we're going to make those cross sections perpendicular to the x-axis. Okay, so we know if we're going perpendicular to x, we're using the same segment, so we don't have to change the functions. And who we want to square, so that's an easy thing. Okay, so the same moving segment we saw, that is really forming one edge of every square that's going to be sticking straight up. And since that's a little bit more of a, we have to do something with it, let's call that b of x. So b of x is the same thing we did before. We take the top function, we minus the bottom function, and as we move along the x-axis, that determines how long that piece is. Except this time, we need to add up areas, and since this is a square, that's b of x, and we're going to add up an infinite number of areas, so we're still going to integrate. And how do you get the area of the square? You take one of the sides, and you square it. And we need the differential, and we're still going from 2 to 5. All right, one more. Okay. Now we're going to switch and we're going to look at region 2. Let me play with my pen colors. All right. And we're going to do around the x-axis. Okay, so region 2, and if I notice, the x-axis is one of its edges. That means as I revolve it, I'm going to get kind of this neat like silo shape. I don't have any holes in the middle, so I can use the disk method, because I'm essentially making these tiny discs. Okay, so each disc is essentially a circle or a little slice of a cylinder. So we have to describe the radius. And here's put the radius. So start from the line of revolution. I'm gonna go up to the edge of the region. And that would just be this function. So this radius is always gonna be 1/2 times whatever the x number is squared. So I like to define that. It just makes it easier if I'm typing or, okay. But this time we're going to add all those circles. So how do you get the area of the circle? You take the radius, you square it, you have to times it by pi, but we're adding an infinite number. So we need that. And we're going from 2 to 5. All right, I'll see you in a little minute because we're going to talk about the last one.